So the reaction I'm going to be going over today is the reaction of turning roasted iron ore into liquid iron, or pig iron. So in order to do this, we have to have the roasted iron ore, and then we add it with some coke in its solid state, and when reacted with heat, we'll get liquid iron and CO in its gaseous state. So when we look at this in the blast furnace, we have to add in roasted ore, coke, and limestone, and a bunch of different reactions take place. So the first thing we do is we'll take some of the roasted iron ore and we'll react it with some CO in order to form some Fe3O4, which we'll take to with some more CO to make some FeO, and we'll finally take that with some more CO in order to create the liquid iron that we were going for. So the overall part of the reaction takes place in the first three sections. But in order to do that, we need to get the CO from somewhere, and we also produce a lot of CO2. So that is solved in the second three equations, in the fourth, fifth, and sixth equations. If you see right here, this equation takes place in multiple places, multiple temperatures, and it's the equation of C plus CO2 equals 2CO, and that will produce the CO that we need. Um, we do have, and then another thing that we will be using will be the limestone, which is CaCO3, and we will be using that to create some CO2, but it will also create some CaO. And the CaO we will react with some SiO2, and that will make CaSiO3. Now the CaSiO3 isn't very important, and it's basically all of the non-commercially relevant parts of this process. And so it's called the slag, and will go out to the left of the place of the blast furnace. Next, the last process that we have is turning the C, some carbon and some O2 into CO2. And this CO2 is used in some of the C plus CO2 processes that we saw earlier, but the O2 we actually get some from some preheated air that we have around here. Um, and the C is from the coke that we put in earlier. And the output of this is, of course, the liquid iron, which will turn into little bars, which are called pig iron due to the fact that when it hardens, it looks like a bunch of little pigs suckling a mama pig. And the byproducts, by some of the waste that comes out is the slag, as well as some of the air that comes out of the vent, the C, CO2, and N2. And that's the main process that happens in the blast furnace. And the reason this is useful is because it's used in creating steel, which is one of the most commercially useful products ever. Um, Steel is used for making cans, it's used for making skyscrapers. A main reason that iron's useful is because it's, when coupled with the making of steel, started the Industrial Revolution, which started the railroads, and the railroads made it so where we were able to transport things so much quicker and start up a lot of different types of business. And the last reason that pig iron is so important is because it's used to as an easy way of transport to get the so you don't have to have the blast furnace and the steel refinery in the exact same place. You can have one in one place and one in another, and you can easily transport them because it's in little ingots. And so, in conclusion, iron is one of the most useful resources in the modern world, and the only way it can be made is by turning the iron ore into pure iron called pig iron.